Okay, this is the midterm quiz. This is the one for Physics 203, but all the quizzes were similar and covered basically the same material. So while yours might be a little bit different from this one, I think that this one will be useful for you. So the first is, what is the standard error in the following set of numbers? So first you have to find the average, and the average value for x is the sum of the individual values divided by the number of values. So that's 8 plus 9 plus 12 plus 7 divided by 4, which is the number of numbers, and that's equal to 9. And then to find the standard error, it's the square root of x minus x bar squared, the sum of these, divided by n minus 1. And so that is, the average is 9, so it's the square root of 9 minus 8, which is 1 squared, plus 9 minus 9, which is 0 squared, plus 9 minus 12, which is 3 squared, or negative 3 squared, but it's absolute value, and then 9 minus 7, which is 2 squared, divided by 4 times 4 minus 1, and that gives me 1.1. Given the area of a rectangular piece of board, it's given by length times width. Given these values for the length and width, what is the uncertainty for the area of the board? So I have the average length and the standard error given here, and the same for width. So I need to calculate first what is the standard percent error for the length, and that is the standard error, which is 2 divided by the average times 100, so that's equal to 17%. And then the standard percent error for the width, which is 3 over 15 times 100, and that's equal to 20%. And then to find the standard percent error for the area, it's the square root of SPEL squared plus the standard percent error of the width squared, so that's 17 squared plus 20 squared, and that's equal to 26.2%, or just 26%. And then I want to calculate the standard error, so I say that the standard percent error, which is 26.2, is equal to the standard error in the area divided by the average area, which is just 12 times 15 times 100. Solving for the standard error in the area, I get 47. And let's see, the units are that. Are in square meters. Alright, the following data was taken for an object being shot upwards with different speeds, v. The object went up to heights h. The relationship between the two quantities is as follows: half mv squared equals mah. Now you should have looked at this, and you have to rewrite it a little bit. Your m's cancel here, and then I can multiply both sides by 2. So I could rewrite this as v squared is equal to 2ah. And then I should know then that I plot v squared on my y and h on my x, and that's what I've done here. I have v squared and the height plotted on the y and x axes. And then I find my slope, and here I find the slope to be 19.6. Alright, you would draw the delta y and delta x appropriately. Slope is equal to 19.6, and then that slope, 19.6, is equal to twice the acceleration, and so I just solve for a, and it's equal to 9.8 meters per second squared. Alright, below is the graph. Oh, by the way, on this previous problem, not many people got this correct. Most people plotted v and h, and if you did that, I automatically counted off 10 points on this problem. So most people did not plot that correctly, but that's the whole point of the problem, is that you plot the appropriate variables and that you make it a linear plot. Below is the graph shown as period squared versus length of a pendulum, and I give the equation of this function right here. Find the slope and the y-intercept. Or if you find the slope, picking 2 points, the slope is equal to 4, the y-intercept is equal to 0.4, and then I use that in order to find the acceleration due to gravity. This is my term for my slope. So my slope is equal to 4 pi squared over g. So g is equal to 4 pi squared over the slope, which is 4. So that's equal to pi squared, which is 9.86. And then my y-intercept is 0.4, and my y-intercept is given here. So b is equal to 4 pi squared over g times r, recognizing that 4 pi squared over g is just equal to m. So I say just b is equal to m times r. So r is equal to b over m, which is 0.4 over 4, which is 0.1 meters, or 10 centimeters. Sketch the velocity versus time graph for a bounce pass, a ball that is bounced from one person to another. This is just like in the class. Here we have a bounce pass. The velocity versus time looks like this. Initially, before the bounce, the velocity is increasing in the negative direction, and then it bounces, and there's a discontinuity here, and then it's decreasing. The velocity in the y direction is decreasing in the positive direction. Using trig, calculate the sum of these two vectors. All right, you want to find the x and y components of all these vectors. The x component of A is 30. The y component of A is 0. The x component of B, write this up here, is equal to 10 cosine of 30. And that's equal to 8.7. So this is 8.7. And then the y component of B is 10 sine of 30, which is equal to 5. Alright, so there's my x and y components. I want to know the sum. If we say that r is equal to a plus b, then to find the x and y components of r, I just add up the x and y components of a. So this is 38.7. I add up the x and y components of a and b. And so the y component of r is 0 plus 5, which is 5. So those are my x and y components. Now to find the magnitude, I use the Pythagorean theorem. It's the square root of 38.7 squared plus 5 squared. And that gives me 39 meters. Actually, newtons, excuse me. So that's my magnitude. And then to find the angle, it is the inverse tangent of 5 over 38.7, which is equal to 7.4 degrees, and this is above the positive x-axis because it's in the first quadrant. Now in this one, you're supposed to use the graphical method in order to draw these vectors and determine the sum graphically. Let's see, big part of this was finding the scale using if you want to get the vectors on a sheet of paper in the landscape mode as I dictated. So this would be your sheet of paper. Alright, your scale, the best scale to use is 1 centimeter equals 2 newtons. In that case, the first vector is going to be 15 centimeters long at 0 degrees, so it would be like this. It would be 15 centimeters. And then the second vector is going to be 5 centimeters. And this angle is 30 degrees. You'd measure that with your protractor. And then the resultant is this vector. So you need to measure the length of this vector. Let's see, I found it to be 19.6 centimeters in mine when I did it. And that corresponds to, well, I'll just say 19.6 centimeters times 2 newtons per 1 centimeter. So let's see, that is 39.2 newtons, which is pretty darn close to what I had found. So my percent difference for the magnitude would be 39.2 minus 39 divided by 39 times 100. And that is equal to 0.5%. I expected less than 10% for the magnitude. The angle is a little more difficult to measure. Let's see, I measured this angle to be, when I did it, let's see, 8.5 degrees. And that gives me a 15% difference. The angle is a little more difficult to do. Alright. Number 8, you're supposed to just sketch how the x and y components. I took a variety of answers on this. A lot of you described it in words, and I would accept that. Really what I was looking for was simpler than that. Just wanted you to draw the vectors. This is the y component of the velocity. It gets smaller as you go up until it goes to 0, and then it gets bigger as you go down. and then the x component of the velocity doesn't change throughout the motion. This is just like the figure in your lab manual. It's the one I showed in class. Alright, a ball is launched from a spring-loaded gun as shown in this figure. The y displacement is 2 meters. The x displacement is 3 meters. I want to know what time passes before it strikes the ground. In order to do that, for part A, this is A, B, and C. For part A, you consider the y motion. Say y is equal to 1/2 at squared, because the velocity in the y direction is initially 0. And so my y displacement is minus 2. That's equal to 1/2 minus 9.8 meters per second squared, t squared. And if I solve for t, I get 0.64 seconds. Just like in the lab, t is equal to 0.64 seconds. What is the initial velocity of the ball? Well, for part B, I know that it goes a certain x distance, and this is going to equal vx times t. And so my distance that it goes is 3 meters. Vx is what I want to know. The time that it takes to go that 3 meters is 0.64 seconds. And so Vx is 3 over 0.64, which is 4.7 meters per second. At what height from the floor would you place the target placed 1 meter from the table? This was a little more complicated, so it counted for a couple more points. The point distribution, by the way, on this was 3 points, 3 points, and 4 points. So on C, you first had to find the time. X is equal to Vx times t. X is equal to 1. Vx is equal to 4.7. You wanted to find t. So t is equal to 0.21 seconds. That's the time when the projectile is 1 meter in the x direction from the original position. And then you want to find what is the y displacement at that time. And so the y displacement is equal to 1/2 ayt squared. That's equal to 1/2 minus 9.8 times 0.21 squared, and that's equal to minus 0.22 meters. I generally took that if you had some sort of qualifier that it was the distance that it dropped. But really what I had asked is at what height from the floor? What height from the floor? Well, I know that it starts here at 2 meters, alright? And so I just say, let me pull this up here, 2 meters minus 0.22 meters, because that's the distance that it drops. That's equal to 1.78 meters. So that is the distance that you place the target from the floor. You place it 1.78 meters from the floor. And that's the end.